Okay, Year 12s, hopefully by now you've had a look at the couple of Edrolo videos for normal distribution chapter 16. I just want to talk about a few things that it would have covered that are really important. You might want to take these notes down, up to you if you want to press pause at some stage. So chapter 16, normal distribution. So it's also known as the bell curve, okay? And that's obviously because it looks a bit like a bell. And I'm pretty damn hopeless at drawing these things. That's not bad for me, actually. So we always have the peak in the middle, which we will find out is the, or you should have known by now, which is the mean. And we talk about standard deviations either side. The other thing that's really important is this is for large samples. So it might be something like test results for all year 8s across the whole level. So for us, it would be 250 kids test results. So you don't do this sort of thing for, a group of 10 people. So it's a big sample. All right, the properties that are important, some of us will know half of these already, hopefully. Property is determined by the area under the curve, and the total area is always equal to 1. So if this is going to run into the axes, we're talking about all of this, is always equal to 1. Okay, it's never negative, which is quite obvious because it's an area. Mean equals median, which equals mode. So this is in the middle here where we have our mean. In these kind of bell curves or normal distribution, it means the median is equal to that mean, which is also equal to the mode, because the mode obviously is going to be the highest one, most often occurring, and the median is the middle number. So if it's symmetrical, which leads into the next one, then these three all have to be equal to each other. So there's some important things there that you would have learnt in year 9 and 10, but perhaps have forgotten. The mean determines the location of the middle, all stemming from what we've done, and the standard deviation determines how wide the curve is. Okay, and the two things that these are responsible for, the mean will shift the curve to the left or the right. So for instance, this one up here, if this was 0, that would mean the mean is 0, but if the mean was 2 and standard deviation is just 1, so it's just a normal looking curve. Oh, see, now I've gone up too high. It would be that one. And I'm going to put my 2 there now, okay? So the mean shifts it to the left and the right. However, the standard deviation changes the height or the width. So here in the normal one, we have a standard deviation of 1. If that standard deviation is less than 1, then you'll find it goes up quite narrow. And if it's a higher standard deviation, then it becomes a wide graph. All right, so we're going to have a quick look. We're not going to do everything on here because hopefully you have looked at the values. But if you have a look at your booklet for 16A, values, I meant to say Edrolo. So if you've looked at Edrolo, you will have come across this pretty ugly looking formula here, which we don't actually have to integrate by hand. All right, so you need to know what it looks like, and you need to know the important things like the standard deviation is here and the mean is here. All right, and these are really important too, so keep this piece of paper or write them out. If you want to know what has happened, so what is the graph looking like, a lot of us can just look at it and decipher by looking at it, but if you're not one of those people, you can follow what is here. So as I've said before, translating by the mean, units on the x-axis, so we would look at what this is to get that, dilated by a factor of 1 over standard deviation from the x-axis, so whatever the number is there, and dilated by 1 over that number, dilated by a factor of that number from the y-axis. So what on earth does that mean? Let's have a look and see. So if we have a normal distribution, so we have mean is 2 and we have a standard deviation of 1/2, state the transformations that have happened. So the first one, I always do translation first. So it is translated by, and if we just follow this, or by what I've been talking about today, it's going to be translated by however much the mean is. So it's translated by 2 units in x-axis is the first thing that happens. Okay, the next thing that happens, if we come up here it is going to be dilated by a factor of 1 over standard deviation. So the standard deviation is here, it's the number in front of the square root sign, or in this case it actually gives you the number, which is a half. So if we're going to put it into a half, then it's 1 over a half, which is 2. So dilated by a factor of 2 from the x-axis. Okay, so the x-axis one is the 1 over the standard deviation, and the last one is dilated by a factor of, if we look up here, standard deviation. So in this case it's a half from the y-axis. Okay, so that's basically theory from what you've got here as to what it looks like. Okay, sketch the graph of the distribution above on the same axis as the standard. As I said, I'm really no good at these. So if this is 0 and we do a standard, and then we're going to go 2 over here, and we're going to dilate by a factor of 2 from x-axis, so it's going to go up high, and then dilate by a factor of a half from the y-axis. So we're going to go up here. Oh, goodness me. And the two, I should draw them in after I've done it, because I'm no good at it. Okay, so it's going to look something like that. Just as long as you have a general idea of what it's going to look like. All right, so how do we use our CAS when we have to play with this? Consider the normal probability distribution function. Here it is. Okay, what is this going to be in here? So we have a 3. So in front of the square root sign, that means standard deviation of 3. And our mean is x minus whatever the number this is. So our mean in this case is 2. All right. Just getting you used to doing that. You don't have to, that's just sort of practice. You don't need it for this. So use your CAS. So we've got from negative infinity to positive infinity. That is the button if you haven't found it yet. Gosh, hope you have. But so we need to go to integral. I think it's menu 4.3. Calculus and then integral, but don't quote me on those numbers. So menu, calculus, integral. And then this here is in the pi button. I think it's third over or something. And then it's f of x. So in your calculator, you're going to put all of this. 2 pi, a negative a half, x minus 2 over 3 all squared, dx. Now, that is simply putting it in your calculator. So I'm going to give you the answer. The answer that you're looking for is a 1. All right, so what does this mean? This here is finding our mean. Okay, so they want you to find a mean as an integral. So we're going to put our integral sign. It doesn't say from one spot to another. So in this case, it's infinity again. And all you have to do is multiply x by all of this. Okay, I'm going to write f of x because I can't be bothered, but it means putting all this in. Now, I hope when you're doing questions like this, you're using your calculator where you press the up button and you land on the last one you've done and you press enter, because then it will put it back onto the calculator for you, and you can go in and just go back to here in your calculator and put an X. All right, if every time you're putting this into your calculator, then you are wasting a lot of time. All right, so hopefully you can do that and you should get a 2. All right, and the last one we're going to look at here is the same, but now it just says finding x squared, so we're simply going to go x squared times whatever the function is. And this is dx. Again, I'm going to say it, so you press the up arrow on your calculator and enter, and you'll be here. Go to here, because that's what you did last, and put a squared in, and hopefully you're going to get 13. So have a practice of that, and make sure you know how to use your calculator. I think this is the same as question 4 that you're set in 16A. All right, we're going to have a look at 16b same time. Just bear with me while I turn my page. All right, hopefully from what you've done in class or from watching the Edrolo videos, you are well on your way to understanding what's happening with this bell curve. So 68% is in here between 1 standard deviation, 95% lies between 2 standard deviations, and 99.7 is between 3 standard deviations. So this little thing you're going to draw here is going to be really something you might want to remember because you will be using it. Oh, I'm so bad at these. Oh, that's not bad. Okay, I'm quite happy with that. All right, down the middle. So I'm going to draw a separate line for my Z. Okay, what is Z, you say? Z is the standard deviations, okay? So for in the middle, your standard deviation is 0 because you're not going anywhere from the mean. So Z equals 0 at this point. We're going to go to 1, 2, 3 standard deviations and 3 to the other side. All right. Now, if you see this as a number line, that's fine, but I'm going to put them down here so that it is like a Z line. So this could be X, and this could be, actually we won't worry about that, but if you think about that as Z, okay, because you're going to start seeing Z and it means the standard deviations. All right, so this question says, consider the curve is symmetrical, draw it and break it up into smaller sections to show the probability of each. All right, so we're going to go this first section here. So 1 standard deviation either side. As we can see from this one, it's 68%. Okay, so that means within each of these, each one of these is going to be 34%. Or as a probability, it's going to be 0.34. Okay, so when you're asked about probability, remember, we want it to be under 1. All right, let's do the next lot of standard deviation. So now we know this next bit. 2 standard deviations is 95%. Okay, how do we work out what's going to go in here and what's going to go in here? So if this is 95 and this is 68, then that means this plus this must be 27. So 95 minus 68 equals 27. And a half of 27, because we want half of it in here and half of it in here, is going to be 13.5. So in here we can say, just like we have up here, 13.5%, 13.5%, and as a decimal probability, 0.135. Okay, we're going to do the same. We're getting a bit complicated with writing now, so hopefully you're doing this at the same time as me. So now we're entered our 99%. All right, so we had 95 here. We've gone to 99, so we've used up 4 more percent. No, it's 99.7. I knew that wasn't right. 99.7. 99.7% from 95, so we've used up 4.7%. We want to split that into 2 halves. So this is going to be 2.35% in here and 2.35% in here. So as a probability, it's 0.0235, which is tiny, obviously. All right. If you were going to add up all of those, you would hope you would get all of these 99.7, because that's what you're saying you want to use up between 3 standard deviations to the right and 3 to the left. So if we've used 99.7, it means we've got 0.3% left. So there's going to be 0.15% in here, 0.15% in here. So that's 0.015, 0.015. Okay, so that's where all those percentages work. Now, you don't have to remember that off by heart. You want to use it so that you want to know it so that you can answer some of the questions that are coming up. So let's have a look. The height of the volleyball players at the Olympics follows a normal distribution. Good, that's what we're doing. That means it is a bell curve with a mean in the middle, with a mean of 198 and a standard deviation of 4 centimeters. Sketch the curve. Okay, so we're going to go curve. Oh, I'm not doing bad today. Can't even begin to tell you how bad I am at these. All right, so this is in the middle, so it's going to be 198, and 1 standard deviation is 4 centimeters. So I would go up by 4s. 202, and let's go 3 standard deviations. Oh, I've written 3 then. So 206 and 210. And then if we're going to go down, we're going to minus 4 each time, ending at 186. Okay, so this is actually the height that we're talking about here, okay? It's not Z. So the difference with your Z is that that's why I said before, draw another line, and I've run out of room. If you were to draw a Z line, this would be 1, 2, 3 along here. Okay, state the intervals that contain 68, 95 and 99.7. So these are the ones you're always going to use. So 68%. So 68% is 1 standard deviation either side of the mean. So if we look at the graph you've just drawn, that's going to be 194 to 202. Okay, next one up is 95%, and that's 2 standard deviations either side. So that's 190 to 206. And then we have 99.7%, which is 3 standard deviations, which is our last bracket, 186, because we've gone 3 times 4 and we've taken that from 198. Or we can do 3 times 4 and add that on, and so that goes up to 210. All right. What is the probability that a randomly selected player is taller than 194%? So we want probability that X is greater than 194. Okay, so let's have a think about what we've got. If we have a look at this, we've got all of this. Now, if it is symmetrical, it means all of this must be 50%. Okay, and I'm going to go straight for decimals here. So, yeah, 50% is used plus this amount, which is 1 standard deviation from the mean. Now, if we look up here, 1 standard deviation from the mean was 0.34. So it's 0.5 plus 0.34, and our answer is 0.84. Okay, what is the probability that a randomly selected player is shorter than 206? So probability X is shorter than 206 is going to be, all right, let's have a look. 206 is here. So you could do it a number of ways, couldn't you? You could take away, you could do 1 minus what's above it, or you could do it the way we just did before. So I'm going to go back and do it this way. So the first bit is a whole half, so it's going to be 0.5 plus, now this is, let's go 1 standard deviation from our mean, as we just said in the last question, is 0.34, plus the next part, so another standard deviation, is plus 0.135. So your answer for this question is 0.975. All right, and there's one last thing you need to do, but it's pretty simple. It's just putting stuff into a formula. I talked about Z. Now, Z is the distance, the standard deviation, how many standard deviations from the mean that we're going. So it's not 202, 206, it's 1, 2, 3, okay? And to find this out, we use this formula, which is pretty straightforward, x minus mean over the standard deviation. Well, you do this so that you can compare two things. So we've got a guy's team, oh no, I thought they were a team, they're not, men's heights, and we've got ladies' heights. And you would say, well, we can't really compare ladies and men's, but we can compare them within their own groups and therefore against each other. And this can be done using our z-score. So, for instance, find David's score. So suppose the mean height of males is 180 and its standard deviation is 8 centimetres. Now, David is 189 centimetres, and we're going to find out what Z is. So Z is equal to, what do we have? We have a mean for the group of 180, and we have a standard deviation for the group of 87. Oh, 87. Why did I say that? 8. So Z, the formula is x minus mean over standard deviation. X being what you're given, one person's score or one person's height or one person's whatever. Okay, so we're going to go in here, 189. Subtract the mean of the whole group and divide it by the standard deviation. And if you put that into your calculator, you should get 1.125. Now, it's a positive number. It means David is 1.125 standard deviations above the mean, okay? So if we're going to look in this part, he's somewhere in here. So he's taller than all these people, at least, okay, which was like this question. So he's taller, that was one standard deviation from there. Yes, it was. So he's taller than, approximately 0.8 of his group. All right, so let's have a look at hers, a lady. So we've got Ellen's, the mean for her group is 160 and the standard deviation is 6. So Z is going to be 165.5. We're looking in here. Subtract the mean divided by the standard deviation, and you should get 0.92. So this means within her group, she's almost one standard deviation taller than her average person, okay, or the average of the group. So she's definitely taller, he's definitely taller, but because the Z value here is greater than Ellen's, it means relative to his group, he is taller than she is within her group, okay? So David is taller in relation to his group than Ellen is in relation to her group. Okay, and in other words, I'm going to go back over and scribble on this. I know that's 100. If we go here, he is about here. Or actually, he's about here. Z is 1.125, and she's somewhere here, 0.9. So he is taller within his group in relation to her being taller within her group. All right, that is 16A and B.